All right, we're going to go 4.4, properties of logs. And so what we're going to do, we're going to kind of work first with this kind of the addition, multiplication idea of logs. So here it is. Let's say that you are presented with something that goes log, and inside the log, no matter what base it is, let's say there were two things, x times y, right? One of the properties of logs tells us that we can separate it into its same base, log, same base, x, plus log, same base, y. So that's one of the first ones that we have, right? So now it can be any base of log that we want. So let's say that they gave us log base 4, 10x. So you see that there's two different things in there. There's a 10 and there's an x, just like there was an x and a y up above, right? So let's do this. Let's go log base 4 of 10 plus log base 4 of x. There, we just changed it, right? Pretty nicely done. Okay, so that's one of the things we got here. All right, let's try this. Express as a single algorithm, simplify if possible. All right, so check the first one. It's log base 5, log base 5. Okay, so since we have the number, and they're adding these two things, that means since they're the same base, let's just squish them together and let's go log base 5. And inside there, it's going to be 50 times 62.5. See how we're just reversing what we did earlier? Let me show you what we did earlier. Remember, earlier we reversed it and we split it into the pluses. Now we're going to condense it back down together, right? So that it looks like that. So then let's go ahead and let's go log base 5 equals 3125. 3125. Just put that in my calculator. I got that like that. All right, good. We'll leave it there. Done. All right, let's try this one. Here we go. So first of all, are they the same base log? You bet they are. So let's do it. Log. Now, I'm going to take a pause for a minute. If you see log and you don't see a number base here, that means it is called the common log. And the common log is log base 10. So just know that if you don't see the log number there, that means it's in log base 10. So here we go, log. Now we're going to take the junk times the junk. Right? That's exactly what it would be. And then if we continue to simplify it, now it would be log base 100,000. 100,000. Log of 100,000. There you go. All right, let's try this one. You try. Ready, go. Okay, let's see if we got it. Log base 3, because there's both log base 3. There's the numbers that are being attached. 3 times 27. So then we're going to go log base 3 of 81. I guess you don't really need the parentheses there, but I like parentheses. There. Okay. Hopefully there you feel good about doing that property. All right. Let's talk the next one. Okay. So the next big property, I'm going to come back up here. That's the addition multiplication. Let's do the subtraction division. So if I gave you log x divided by y, then that can be written as log x minus log y. Now whatever's on the bottom, that's the one that gets subtracted. Okay, so let me give you another one. Log base whatever, log base 3. Let's say that it was x over 10. Now that's going to be equal to, you ready? Log base 3 x minus log base 3 10. Okay, let's go ahead and put another property. Okay, you got these properties, addition, multiplication. You got the subtraction, division. Let's do the exponent. Exponent property. Okay, so check this out. This is going to be where they say log of x squared. So what's kind of cool about the exponent property is we literally get to take this exponent, and the property says you are allowed to put that in front, like, so take the exponent off and throw it in front. So this is actually the same as 2 logs of x, right? That's kind of cool, huh? Right, so let's do this. Let's go log x to the 5th power, okay? Take the exponent, throw it in front, and it equals 5 log x. Right? So that's the exponent property. Okay, so again, here we go. Addition, multiplication. So going from addition to multiplication, subtraction, division. We got exponent property. Perfect. Okay, I want you to add one more thing to our repertoire of things that we're doing right now. Let's do what we call the change of base formula. Because I want to be able to put stuff in my calculator, right? So we're going to do this. So we're going to put some certain things in our calculator. So the change of base formula, let's say it's log 3 of 27. Okay, so we don't actually have a calculator function for log 3. So what we can do here is you put the base in the basement. Okay, that's a cool saying. Okay, the base in the basement. So we're going to do log of 3. So we're going to do what we call common log base 10. And on the top, we're going to do log 27. Okay, so that's going to give us our answer. That's the change of base. All right, let's try it again. Let's try something real quick. Log base 5 of 100 equals, here we go, log 100 over log 5. That's it, right? So that way we can use our calculator to do it. So let's do one more. Log base 11, and let's say we have the number 20. So here we go. It's going to be log 20 over log 11. All right, so let's try to find some numbers here. Pull out your calculator. I want you to find a key on your calculator that literally says log. This is the common log button, which means log base 10. Okay? Do this for me, if you will, once you're in there. Let's do this in my calculator. Log of 20 equals. All right, so let's hit our log button. Let's put 20 in there, equals. You should get 1.30. What does that mean? Remember, there's a base 10 there, right? That's always what, you don't see it, but that's what it is. So it's x to the 1.30 equals 20 here, okay? So 10 to the 1.3 equals 20. So put that in my calculator, 10 to the 1.30. Now, I rounded it, so it's going to be real close to 20, but not exactly 20. But that is fun, because that's a log button in my calculator. All right, let's try again. Let's just do another common log. See if we're getting the same answer when we do this. Let's go log, still base 10, so that's our common log of 10. All right, 10 to what power is going to equal 10? What do you think this is going to be? That's right, it should equal 1. Awesome. Okay, so then we want to expand a little bit, and sometimes I want to do log, base 5 of 10. 5 to what power equals 10? I don't know. 5 to the squared is 25. 5 to the first is 5. So what is this going to be? Okay, since I don't have a log base 5 button in my calculator, we're going to do change of base. Change of base. Here we go. It's going to be log 10, put the base in the basement. Okay? Now, literally in your calculator, put log 10 divided by log 5 and go. You should have got 1.43. So log base 5 of 10 is equal to 1.43 via change of base formula. All right, let's try it again. Log base 7 of 10. Okay, change of base. Log 10, log 7. Put the base in the basement. Equals. All right, here we go. In my calculator, log 10 divided by log log, sorry, I hit the wrong button. I had to go back. Log 7. So log 10 divided by log 7, and I get 1.18. That's using our calculator to help us out when the base doesn't work out correctly. Okay, now let's use property, addition to multiplication, division to subtraction, exponent property, change the base formula. Let's see if we can't get things together. All right, here we go. Log base 9 of 1 over 27. All right, automatically I see a fraction or a division. So I am going to think about, let's expand this. Log 9 of 1 minus log 9 of 27. Great job on expanding. That's what the expanding looks like, okay? So now, if I wanted to, I could either put this in my calculator and think log 1 divided by log 9 and see if I can get an answer. But I also know that 9 to what power should equal 1? The only power that can change a 9 into a 1 is 0. So log 9 must be 0. Okay, if you don't know, let's do a change of base. Let's go log 9 divided by log 1. And go to. So mine right now, it's saying error, right? Why is it saying error? It's because it knows that it creates a 0 on the bottom of a function, right? And it can't create a 0 on the bottom of a function. So this actually is one that we need to mentally process versus actually putting that into our calculator. But we know it will be 0, and the calculator has a hard time with that sometimes. I'm doing that. Okay, let's go log 27 over 9. So I'm thinking about 9 to what power equals 27? I don't know. So let's do change of base, because 9 to the first power is 9. 9 squared is 81. So it's not going to be quite 2. It's going to be somewhere between 1 and 2. Okay, so we got to figure that out. So let's do change of base formula in our calculator. Let's go log 27 divided by log 9. Okay, I get 1.5. So evaluating this, negative 1.5 is what this ends up being right here, right? So trying to use our bases to do that. Okay, let's just do a straight change of base formula on this. Let's go log 32 over log 8. So in my calculator, log 32, because there was nothing to expand on this, log 8, I get roughly 1.67. That's as the decimal. We could change it to a fraction if I want to. Okay, let's do another change of base on this, because there's nothing to expand here. There's nothing to expand, right? We could try to expand some things, but there's nothing there. So let's just go ahead and go log 10 over log 5. Log 10 over log 5. In my calculator, 1.43. Nice. All right, let's do one more. Nothing to expand here. All right, so let's just go log 27 over log 2. All right, guys, getting down with this change of base formula. It's not too bad, is it? 4.75. And again, what does that mean? It means that I would have had to do 2 to some power equals 27. That some power should have been 4.75. Roughly, that's rounded, right? Okay, let's continue to simplify. Ooh, check these out. We got some exponents, so that gives us the opportunity to expand a little bit. So that looks like a log base 8. All right, so then exponents, what by the property means we can put it in the front. 2 times log base 8 of 8. Okay, do we know what this is? 8 to what power is going to equal 8? This, my friends, is going to equal 1. So it's going to be 2 times 1, because that's going to be the power that can give you 8. So 2. We evaluated. Nice and easy. All right, let's move to the next one. Let's move the exponent to the front. So now we got 5 log base 3 of 3. Oh, what is this? Just like it was just right next door. 5 times 1, this is going to be 5. Nice. Okay, okay. Continuing along. Here we go. Move the exponent to the front. We got 3 log 7 of 49. Okay, what power is going to, would I have to put on here? 7 to what power equals 49? That's right, a 2. So 3 times 2, so this is 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. 6. Okay, move the exponent to the front for log 1/2 of, and this really becomes 1/4, right? So how do I make 1/2 become 1/4? You would have to square it. So this is 4 times 2. So this is 8, right? It's all about working this out right now, right? A change of base formula would also help us on those, right? If we wanted to. Okay, express the single logarithm as a single logarithm. So check this out, base 4, we see subtraction, let's work backwards. That's gonna be log base 4 of 320 on the top, 5 on the bottom. So we could, if we want to, log, if I'm gonna go 320 divided by 4, if I wanted to do that just a little bit further, you would have 80 on there, okay? So there it is expressed. All right, let's try this one. Logs are on the same base, so I'm allowed to do this now. Log of 5.4 over 0.054. Technically, this is what they're looking for. Let's see if it simplifies down any. 5.4 divided by 0.054, and we get log of 100, right? So, oh, and remember, if you don't see it, it's really got a base 10. Right, if you don't see it. So actually, I know that this actually is going to equal 2, because really we're trying to think about what power would I have to send this to get there. It'd have to be the second power. So you could go all the way there if you need to. Okay, and so that's kind of the basic idea there. All right, last little bit here, inverse of a log, inverse of a log. So let's say that we had x is equal to log base 8 to the 15 of 15, okay? So that's what that looks like right there. So inverse of log, so this is what it looks like. Now, we've already talked about you take the base and write it, you take the exponent and put it up, is equal to this number here, right? So that's what it looks like. We know how to do that evaluation process, right? Because we've been doing it. But check this out. So in order to invert a log, then you put this whole side to a log 8. You put this whole side to a log 8. And since they are inverses of each other, this all goes away. And this just drops right out. And then we would say this, 8x is equal to 15. What? That's exactly what we knew already, 8x to the 15. And then we'd try to evaluate that right there. Okay, so let's try another one. Let's say that we have 12 is equal to log base 5 of x. Okay, I want to free the x. So I see that the log base 5 is there, so I'm going to put this whole side to a 5, this whole side to a 5. That cancels out, so then I end up with 5 to the 12th power is equal to x. And then we would continue to solve from there. We put that in our calculator. Okay, so continuing this idea, so we can also work this backwards. What if we had 10 to the x is equal to 2? So something like this, 10 to the x is equal to 2. So it works the other way. We've been talking about this, but in order to invert this, I'm going to go log base 10. So that means I got to go log base 10 over here, right? I got to put log base 10 on both sides. Well, we know by the power rule that the x is going to slide to the front. So now we really have x log 10 of 10 is equal to log base 10 of 2. And we know that log base 10 of 10 is always going to equal 1. So it's really just going to kind of cancel out, if you will, because they are inverses of each other. And you get x log of 2. Now notice I didn't write the base 10 down here because it is the common log. So that's literally what I could put in my calculator. Log 2 equals, and then I'm going to have x equals 0.301. Right? So that's what that works. Okay, so think inverses of each other. This is what we've actually been doing since the beginning of logs. It's just now looking at it formally and seeing what it actually looks like as I start to solve for equations. Okay, so here's some things to make sure you have written down. This property, when you are multiplying two things in there, you can expand it to be addition of two logs. If you are dividing two things inside, you can expand it to be the subtraction of two logs. If you have exponents on there, you are allowed to bring the exponent to the front. and make it a multiplication. And then, of course, I want you to know your change of base using your calculator, using your log button. Go find that log button on there. So then we can do any base. Now, the log button is only for base 10, but we could do a change base where you do base 10 divided by base 10, put the base in the basement.